So good afternoon, everyone. All right. So my name is George. Okay, and we are happy to be with everyone here. Yes, and for the fact that you all are here this afternoon shows that you want to upscale your solar business. Not so. So you want to see how you can use other products to upscale that will give you good results, right? So before I begin, I want you all to give yourself a round of applause for being here. So thank you very much. All right. So now we'll be talking about the charge controller, the MPPT. We all know that for us to have an optimal energy efficiency from our panel arrays down to our battery banks, we need a charge controller to achieve that. True of us, right? Exactly. So if we're not using an hybrid inverter that has an inbuilt MPPT, when we're using any of these, we want to use a charge controller, not so. So on that note, who can define or help me explain what MPPT is? Let's start with that. We talk of MPPT, yes.
MPPT simply means maximum power point tracking.
Thank you very much.
And it charges the battery faster than PWM. So that once it charges to the maximum, assuming that the battery charge to the maximum level, okay, to convert the voltage. After I get to, you now convert the voltage to current. Is that current that we're using to drive the charges for the utility?
Well said. Beautiful. MPPT, right? It helps, is an advanced electronic device that helps optimize the voltage current relationship from our solar array to our battery banks, right? Doing that very, very optimally. Now, there are various charge controllers in the market, but what makes this unique? These are the features of our charge controller. You see, it's adaptable to the 12 volts, 48 volts, 24 volts, and even as far as 96 volts. We have our charge controllers for that. High tracking efficiency and high conversion efficiency. So when we're analyzing the data sheet, we're going to see at how many percent efficiency does this operate on and what makes it very, very more, superior. It has a reverse polarity function or a reverse protection function on our input and outputs on the charge controller. Okay, let's give them. Okay, we'll come back. We'll come to you.
I stand to be corrected.
Okay.
From the word PV means the panel voltage.
Okay.
Coming from the ultraviolet rays. So the maximum that is expected to enter the MPPT, since it's been rated 150, it should not exceed that 150 volts.
Okay.
That is what it stands for.
Well said. We are getting 98% efficiency from using this charge controller. That's why it's a very rugged charge controller. Very, very rugged. So we are getting 98 overall percent or even more. Now let's look at the input voltage from the panels. Right? So when you are using a 12 volt system, your input voltage should be a minimum of 20 volts and maximum of 150 volts. Okay, and we are using a 24 volt system. Your minimum should be 35 volts and 36 volts. Sorry, my eye is not too. And highest should be 150 volts. And if it's a 48 volt system, 48 volts minimum and 150 volts maximum. This guides you when doing your system sizing. You want to factor all of this into consideration. Now there's also another insightful feature of this charge controller. Now the solar panel rated inputs power, right? So for a 12 volt system, let's say you are using a 40 amps charge controller, for example, and your system is 12 volts. The rated input power from your solar array should be around 540 watts. Okay, but then the interesting feature of this is it can take double the size right? So you can take double the size. So let's say your solar array is giving you about 1080 watts. It can take that, but it absorbs the rated inputs. The reason for this is this: during a cloudy period, right, during when the weather is very unfriendly, and you have enough solar array, because it can accommodate double of it, it means it will still operate optimally. You can still get around that 540 watts even during cloudy period. During intense period, it takes that 540. During cloudy period, it can even take more. So this is the beauty of this charge controller, and it's also applicable to a 24 volt, 36 volts, 48 volts, and it's applicable like that. Right, so these are the basics of the charge controller. This makes it more unique, better than other charge controllers you have in the market. So you see, it's a very rugged charge controller. It has all of these features. Charge controller, you can parallel it. It can be parallel. You can use more on your system. You can see him in the site. You know this man? Yes. So this is one of our sites, Ekesin Farm. The owner of Ekesin Transport. He has a very big farm in Ekpe. So he has a very big farm there, fish pond and all of that. So we did a mini grid for him. Yeah, at the time. So we can see that we are even using 2 charge controllers for him. We have other sites we can even use up to 4 or 5 charge controllers depending on your system sizing. So this is a very fantastic feature of this charge controller, something you can't use with other charge controllers. So how do we all feel about this information about the charge controller? Do we like it? If anyone has any question, okay. All right.
If you notice, what was known in that picture was just both charge controllers. Can we have that picture back on, please?
Sorry?
The picture.
The picture, please. Yeah. Even this. This
If you notice, both charge controllers are just, they just connect to the bus bar. The bus bar is actually the battery bus bar. Okay, so all the entire battery system was connected on that bus bar. The inverter took from that. The charge controllers are also sending their energy, yes, to that. Yes. So now I don't know if you might have noticed, if you've done paralleling of MPPT charge controllers before. Some people dissuade. They say don't do it, and that's why I just want to highlight that now. There's this funny thing about some other brands. Their MPPTs interfere with each other.
Yeah.
So the way the charging will go, one will disturb the other one from charging. I've noticed that on some other brands, but this, it was just smooth. Both of them share the load exactly. So paralleling is very well supported on this brand. So if you have multiple PV arrays and then you want to use all those multiple PV arrays, you've already reached the limit of one charge controller, you introduce the next one, you put it, you reach its own limit, you put the next charge controller, you factor all that into your sizing, and at the end all of them will give energy to that same bus bar for the battery bank, and they relate very well. There's not even any special connection cable between them. It's a very smart, very intelligent system. I've tried doing that with some other brands, and then the MPPTs is just seriously disturbing, interfering with each other, but this smooth. So that's the thing about the parallel. That's why we had to highlight it.
Thank you. So thank you very much.
I stand to be correct. Is it the battery, maybe the size of the battery, that will determine if you have to connect them in parallel? Because connecting them in parallel to give us the same voltage, but the current will be increased. Okay. That's the principle behind connecting in parallel. Okay. So why connecting this now? Going to the battery directly from the bus bar. Are you now saying you separate different battery, maybe section them, section of the battery, this one go to this one, this one go to this one? Okay. Can you share more light on that?
Yeah, raising up your hand. You want to talk?
What was done here is that all the battery was connected in series and parallel. That system battery unit there, and for you to that system battery, this 48 volt system. So you series 4 and you parallel. Then the battery, all the battery inlet come to the bus bar. From the bus bar, we feed our inverter. It was still inverter then. That was series. You understand? it was parallel. We parallel the three inverter. It's 48 volts for 3 phase. Phase 1, phase 2, phase 3. Then the inverter feed from the bus bar. The battery feed the bus bar. The charge controller feed from the bus bar. Do you understand? So that's battery bus bar. So at the end of the connections, there will be 2 wire left, the positive and the negative. They feed to the bus bar. Now we have the positive terminal, we have the negative terminal. So from the charge controller, the 2 charge controller is connected to the same bus bar. So they get charge the bus bar. So but the PV feed the charge controller separately. It's 2 different sets of PV. After the series and series, then the 2 stream, 1-to-1 bus, 1 charge controller, while the second one to one. You can see 2 MC4 there, breaker, LCCB there. So the MCCB. So where the DC breaker, where this is the panel wire, and that's also the panel wire. But the charge controller feed back to the bus bar. So all the battery is connected to the 2 charge controller from the bus bar. Is that clear?
All right.
You said that the charge controller has a protecting device
Yes.
in it.
Okay.
That even when one mistakenly put, wrongly placed polarization,
Yeah.
it will protect it. It's only that it will not come on. No, but the regular charge controller that we are used to outside, more especially MPPT, when you mistakenly put PV in before battery, you will just hear
Yeah, an alarm sound.
so this is your device. You said it has a protecting device in it.
Yes.
Can one try by putting PV first? Sorry, based on what you just said.
Okay. Maybe.
Please.
You want to try yourself?
Yes. Still, I know we there's protection, but still we don't want to test these things. Okay, the normal way of connecting your charge controller is battery first, PV next.
Exactly.
Yes, so please try to stick to that. Wait. Yes, try to stick to that. No, really. There's protection, yes, but don't. Yes, don't push it. Although what really causes what I've noticed from experience too is that if the PV voltage is very high, the function of putting your battery into your charge controller first is a form of stabilizing. It first gives the charge controller the voltage that the charge controller should work with. Do you understand? It gives the charge controller what voltage range should I be working with. Then by the time you introduce PV, it will now know how to collect that. And now the battery in itself is a form of where that energy is being channeled to. Do you understand? Now if you send PV energy, maybe a high amount of PV energy only into this kind of MPPT charge controller, that energy does not have anywhere to be conducted to. It's just entering the charge controller with so much force and nothing to connect to send it out to, which is that battery. So that's why you put in the battery first before you put in the charge controller and before you put in the PV, so that it can conduct that energy, it can stabilize it. If you don't do that, if the voltage is high from PV, although I have seen sometimes where some people made some mistakes whereby they put in the PV first, but if that voltage maybe it was low, it's not a very bright sunny day, like an evening time or very early morning time, the total PV voltage may not be very high, but still you have to follow the standard of operation. Put in your battery first
Before your PV.
Before you put in your PV. Don't
Please, my Nigeria people. My Nigeria people. Ha. Now wicked though. Don't do it. Please, don't do it. See, what is Yoruba sọ pé ètò ò dá? Am I right? So what is not good is not good. It's good to do things right. And the reason why all these features are there is just for minor errors, which they know we can make that error. Don't think because they said you have this, you're not going to do it. That is wrong. Don't do it. You understand? Okay. I've made some kind of mistake like that before. That's why I took the mic. I use an SMA, is it SMS?
SMS.
Charge controller. It roasted in my hand. Even the explosion itself, I almost get injured. Because what I put in was almost a 250 volts. It did BOA. And that time I like most time when we make those mistakes is negligence. When you are working, especially as an engineer, you know, our head is always hot. So a lot of mathematics is going on there. Don't receive calls. I make it an habit that whenever I work, no matter that call, I'm not going to take that call until when I'm done with what I'm doing. So that's where most of us make that mistake. So when you are supposed to put positive, you'll be seeing positive, you'll see it as negative. That time all the village people will be activated. And you swap and you do boy, your body will calm down. And I say, but the thought say. So device can malfunction even though there is certain level of guarantee. So that's why it's still better you do it right. So that even though there is a minor error, you can see he can still be able to protect himself. Yeah. I'm not trying to tell you that it doesn't work, but it works, but don't do it. I'm begging you.
Yeah. Also, thank you very much.
My question is that, like, the giant controller contain the 4 level connected cable. The PVC, as in the giant controller, it's half given cable connected, as in PV. Terminal and battery terminal, and the third one is load terminal. I used to see the most engineers used to they used to collect the load terminal. Like, is there any reason, another reason, like why the load terminal spot was there?
You know that load. Okay, yeah, I'm sorry. Okay, so he says that the charge controller usually has 3 places, 3 terminals. One, PV input, the other one is battery, then the other one is a load, DC load. Are we familiar with that? DC load. So how many of us usually make use of that DC load port? Anybody? Have you made use of it before? Well, it's useful, but you just notice that most times that DC load port, but usually, you know, DC load, when it comes to DC load port, you are talking about it will only power direct DC appliances. You know these little light bulbs that come with all these small solar kits that people sell. Those kind of small light bulb DC bulbs. If you have all these DC fans like rechargeable fans, they can work from this port. Yes, they can work from such ports. For as long as the voltage, please take note, for as long as the voltage of that device you are plugging into that DC port is compatible with the battery voltage. Are you with me? If we are charging a battery system that is a 12 volt battery system, and then you now want to plug all this light bulb that is 12 volts, small DC light bulb that are 12 volts, it will work fine. You have a rechargeable fan that works on 12 volts. You know, those maybe they come with all this 12 volt adapter now that you will plug it into the fine, it will work for it. You know, some of these fans, they call them solar fans. That is that solar fan that you're talking about. You plug it into the port. But what you just need to take note of is that the voltage of the battery system you are using must be compatible with the device, with that appliance, with that light bulb, with that solar fan. It's not that you are charging a 24 volt system and then you now want to plug in a 12 volt light bulb or 12 volt fan. It will damage that. Okay, because the voltage, you are feeding it too much voltage, damage. So the best thing, check that the voltage of that appliance that you want to power is 12 volts, the same as the battery voltage. Okay, the battery bank voltage is 12 volts. Or if it's a 24 volt battery bank, if they are not equal, you can desist. Or I know of some DC to DC converters. Yeah, so if you have a DC converter, you can put them in here. If it's a 24 volt to 12 volt converter, fine, that might be for that particular device. But these are some more specialized setups, but with your experience too in the field, you get more of that.
All right, you are clear, right? So most of the load for AC output load is from the inverter. So reason why most installers just neglect it. So just 10 minutes break to just lighten up. So when we come back, what's the time, please? 12:33. So like around 12:45, is it fine?
Yeah. It's not just hybrid, and this is the hybrid one, but this is hybrid and transformer based at the same time. I'm sure we've seen some things like that in some other brands. They have both hybrid, transformer based at the same time, but this is non-hybrid. That is no charge controller in it. That's by definition, right? But this one has charge controller inside. You have the series coming from 1.5. This is the Amuma Plus. This one has from 1.5 kVA. You have it in I think 2.5. Also have 2 kVA, 3 kVA, 7.5 and 12.5. That's this one. Okay, but this one you have it in 2 kVA 12 volts, 2 kVA 24 volts, 3 kVA 24 volts, 5 kVA 48 volts and 10 kVA. It's just their own little. So you figure out which one is okay for your customer. Talking about some of the features, transformer based means is rugged. It has zone protections too. Yes, this Rico Plus had these breakers by the side. Remember the breakers that we talked about here? This also have a form of input breaker, input protection, in form of this particular model. I think this is a 3. Okay, this is 2 kVA. Usually the 1.5 of I'm familiar, very familiar with the 1.5 of this. Usually has this small shootout kind of breaker. Once if there's any form of short circuit, it will just trip out. You see, it will pop out. Then maybe what you should do is that you should check the system, your installation, make sure that once you are there's no connection error or somebody did not plug something that's faulty inside the maybe a plug or a socket somewhere. Check, make sure that everything is okay, the connection is fine. Then you can press that breaker back inside. I'm sure you're familiar with that kind of breaker. One small shootout around this breaker. Good. It has that, but in this case, maybe if we open up the screws inside, for this particular model, this is a 3 kVA. This is a 3 kVA model. Okay, it has it inside. So input protection is very important so that the device will not just suffer AC, fluctuation in the AC voltage in your grid and all that. But still, that does not stop us from always using our appropriate protection devices, your SPD, your breakers. Yes, always still use that. So that gives us like maybe 2 level or 2 steps of protection. Yeah, so if the electricity did not cross this one, this other one can shock it, something like that. We work with lithium in the sense that if that battery is still depleted, it will take the exact voltage in it. For as long as if this is a 24 volt inverter, you give it your 24 volt lithium, it's fine. If it is a 48 volts inverter, you give it the 48 volts grade lithium, it's fine. It will drain that battery accordingly. It will give you the amount of energy you need, and if the battery drains to the very end, you can charge it up. It will charge and wake up. Most inverters don't really have that wake up function. Is if the battery has drained to the very end, you'll be stranded. I don't know if you've ever suffered something like that. When you're stranded, there's nothing more, and it can be particular with some brands like that too. Once you're stranded, there's nothing more you can do. You have to take down that battery and send it to that company's service center. Maybe that's how they will boost it or wake up the cells and then give it back to you. We've suffered that kind of problem once or twice in the past. But with good lithium wake up function, even if that battery has drained to the end, it will take its time to boost charge it. It will come up. So to some extent, lithium function is very supported. No BMS. If you notice, there are even some other types. There are some smaller types of lithium battery that don't even work with BMS. Yes? Yeah, there are some brands that are small. They don't work with BMS. Easy. Connect it to this, you're good. Yes, it has the Amuma Plus, both of them, they have a space for Wi-Fi. There'll be a dongle. You connect the dongle to it, and with that, if there's constant internet in that facility or that area, they will, you can pair using your phone to the app, to the to the Wi-Fi dongle that's there, and then with that information, it will connect to that and always transmit to the cloud. So you can always see what you're consuming, what you're doing, and information about the device. Information about the device you can always, so Wi-Fi monitoring, this guy has it, although this one does not have it. So that, I think that's like one of my major upgrade from this up to this. Supports Wi-Fi monitoring, this one not so much. Although this one still, they all have their where they stand out.
Sorry, sir. Well done. So my question is just on the lithium compatibility.
Yeah.
So like I don't really get, you're saying.
Well, no, there's no BMS on it. Okay, so it's not going to be connected with your BMS. It's just battery, your normal battery terminal connected to it only, and then the fact that it has lithium wake up function, that's where it really stands out. So that lithium battery is the kind of battery that if you drain it to the end, most times it's hard to just use normal, battery charger to charge it up, to wake it up. Or sometimes good. You can see some other people giving their experience, and I've seen cases that we've tried. We could not wake the battery up. We ended up just having to carry that battery, send it back to the service center. But with these kinds of inverter, they will charge the battery. They will wake it up. It will charge, normal charge. Do you understand? There's never that fear of. The main fear with that lithium was always that if the battery drains too far, to charge it back up. Even solar self sometimes, only solar will not even charge that battery to come up. Many times I've seen that even solar alone will not charge that battery to come up. Do you understand? But with the lithium wake up function, it will boost, it will come up.
Base?
Yes, it's transformer based. Yes.
All right,
it
good.
is.
Because
And it can just the same strength that you can see in the Rico Plus. The same strength you can see in the Rico Plus. The ability to handle surge of up to 150%. The same way the Rico Plus can handle surge of up to 150%, the Amuma 2 can handle surge of up to 150%. Good. Question. Does it have deep switch? No. When the things that the deep switch sets in this one, you can set those on the LCD here. What you have deep switch settings such as the voltage range, the battery cutoff range, you set it. It's like buttons. You know, long press on the enter. You know those kind of settings, and you first long press on the enter. It will take you to settings, and then you now go to settings number 1, settings number 2. Those different setting areas. Then you set the voltage range you want. You set the cutoff. You set the and all that. The charging current you want. All that is settable from the screen here. Unlike the Rico that had the deep switches for it. So thank you very much. Thank you very much. So we encourage you to use the wide range of our products, of our global products. They are very, very good.
Now we will talk about high frequency inverter. Frequency inverter series, we call it Ragnar. Ragnar series, it's for 3 capacity, 4 kilowatt, 6 kilowatt, and 12 kilowatt. 4, 6, and 12. What's the feature in Ragnar? First of all, the warranty for Ragnar inverter is 3 years. 3 years. The IB 54. 54, that means you can install it inside and outside, indoor and outdoor. In addition function, the parallel. The parallel for Ragnar, it's up to 12 pieces in parallel. 12 pieces. Okay, when we said parallel, we didn't mention for 4 kilo because 4 kilo it's a small capacity, and in usual you have inverter 8 kilo, you have inverter 12 kilo, so it's not necessary to make parallel for small capacity inverter. But 6 kilo it has parallel function, and 12 kilo it has parallel function. 6 kilo, if I parallel to 12 pieces, that means I can get 72 kilowatt capacity from inverter, right? Also we can parallel to 3 phase, single phase or 3 phase. It depends what you need it. What else? Okay, the PV input. When engineer Daniel he talk about Amoma, we see the PV input for Amoma, it's limited.
It's a maximum of 150 volts.
Okay, 150 volts. Okay, this is the difference between high frequency and low frequency inverter. The PV input and the range for voltage of the MPPT. We will see in low frequency inverter, the PV input, it's for 1.5, it's 800 watt. But here, for 6 kilo Ragnar, the PV input, it's 6 kilowatt also. The same capacity of the inverter, you can add panel. Same capacity of the inverter, same capacity of the panel. In addition, the voltage for the MPPT range, it's 500 watt. Yeah. 500 watt, volt, I mean, sorry. 500 volt. So 500 volt, if we calculated for panel 550 watt, and the VOC for this panel it's 45 volt. 45 volt, yeah. So how many panel I can connect in series? The maximum MPPT voltage it's 500. I have panels, each panel it's 550 watt, and the VOC per each panel it's for 45 volt. So how many panel I can connect in series? Up to 12. Right? So I can reach to 12 panel in series. That means also my cable, it's still in the small size, the thickness. If the distance it's not much, so 6 mm it's enough, right? But please guys, I see a lot here in Nigeria, they use AC cable, not DC cable. It's big different. Okay? Okay, DC cable. And also, when you need to connect panel to cable, you're supposed to use MC4. It's very necessary. Don't cut the cable and tape it. Don't do that. Please don't do that. Yeah, I know. Now, 12 pieces in parallel. Range for MPPT 500 watt. PV input 6 kilowatt. 3 years warranty. This is the features. Okay. All 3 years. Okay. This inverter it's not dummy, so it's heavy for me, but it's not too much. Okay. Let's see here. The inverter it's on and off. But also, I want to mention for this now to remember it when we will ask. The function in AMOMA and RICO, if you off the inverter has bypass mode. You know what meaning bypass. Engineer Russell, he's explained about that. But this inverter, if I off it, no output. No bypass mode in this inverter. If you off the inverter, it will be the output is 0. No output at all. Okay. Here we have parallel, both parallel, 2 parallel cable. In each inverter, it's coming with cable for parallel and the small RG. Okay? Let's consider this the first inverter. And I have inverter here also. How I parallel this 2 inverter? From the second port, I take the cable from here to first port in the second inverter. Then I will bring the RG. I will close the beginning and the ending. Okay? Okay. So see now here it's 6 inverter, 36 kilo. This is a parallel. Let's coming again. Parallel from the second port to first port. Then I will close the beginning and the ending of the inverter by RG. This about the parallel communication cable. Then I will go to the settings. in the inverter and I set this inverter, it will work in parallel as single phase or 3 phase. I will choose. And please guys, when you parallel inverter, first I will on this inverter do the settings of the inverter. Next inverter, on it, do the settings of it. Next inverter, on it, do the settings of it. When we did all the settings in separate, then I can on all together. Okay? Okay. Here we have the BMS port. So this inverter, it's coming with BMS. BMS, that means it's support protocols. Biontech, Growatt, Voltronic, many protocols of BMS. This RS232, it's always we use it if we need to upgrade or check something in the inverter or programming on the application, especially on the laptop. Here we have a dry contact. A dry contact, we use it to on and off generator automatically. So if you want to on generator when you have percentage of your battery, maybe 40%, you can use this dry switch or dry contact, dry contact. Here's the battery boards, PV, load and grid. And it's very necessary, as Engineer Russell mentioned, necessary to earth your system. Connected to earth. It's very necessary. Also this inverter, it's coming with Wi-Fi, but external Wi-Fi. It's optional if you need it or you don't need it. Voltage range for input, when we see in low frequency, it's from 154 up to 265. This is the range for low frequency inverter. We will see in high frequency inverter, the range, it's from 90 volt up to 170. So it's wide range for voltage for input, wide range for input. Okay. What else? The frequency, it's 40, 50 and 60. Guys, also here it's something important to know it. Is the transfer time. When your client, he will ask you about I need to on this machine and don't blink it at all, because some machines like server, if it's a blink, it will off and come up again. So this one, it's not allowed to make blinking in the power. So we have to see in our inverter how much the transfer time, and check your machine how much also the transfer time it needed to don't blink it. Okay, the transfer time here in this inverter, if you use UBS type inside the inverter by the settings, it's 10 milliseconds. But also this 10 millisecond server, it's not accepted. So always they use UBS for the inverter. This one, it's very important to know it. What's the difference between UBS and inverter? The inverter, it will give you the power, it's constant power, yes. But there is a small time to change from PV to battery, from grid to battery, from battery to grid. It's 10 milliseconds. So if your machine is sensitive for this time, it will not work. Okay? So you have to add UBS. But still this time, it's very small. If you compare it in other inverter, it's very small. The range for the PV, it's a start up from 85 volt. So how many panel, at least, how many panel I have to add? As we said, 550, and the VOC for each panel, it's 45 volt. How many panel I have to add at least to start up this MPPT for startup. 2, right, it's 2. 2 panel, at least 2 panels. So I will reach to this 85 volt. Okay? The maximum, it's the range, it's from 85 to 45. 450, I mean 450, but the maximum it's 500, so you can reach in safely to 500. Okay, the charging current in the inverter 4 kilowatt and 6 kilowatt, the charging current it's 120 amps. For 12 kilowatt, the charging current it's 220. Okay, I have a question. All of you, it's engineer and installer, right?
Yes.
Right? Yes. You are sleeping? Okay. Okay. What's the advantage if I have high charging current in my inverter?
High charging current, so the battery will quickly charge. If not take more hours, maybe if it's supposed to charge within 5 hours, it will charge. It will not be more than hour that we want, sha.
If I use a tubular, I can charge a tubular in 120 amps.
If you use tubular,
Yeah.
no, it's high.
Okay.
Because
So
tubular
what's the
is
advantage of this
within,
one?
12 volt, 24 volt, or 48 volts. So if it is tubular, you can't use that amount of charging currents.
Okay. If I use lithium.
If you use lithium, it's okay.
Okay, but also lithium, the charging current it's maybe 100. So I can use 120 or 200.
You cannot use 120 on 100 because it's higher than the battery.
Okay, so what's the advantage of this value? Why it's big?
Since the system is being programmed to 100, according to you, and we are bringing about the charging current is 120, it will charge faster. That is the time of charging, it will be higher. But as time goes on, it will be having effect on those components.
Okay, you are close, but the real answer is when this charging current it's high amount, so it's easy to you to have a bigger backup storage. So you will parallel 2 or 3 or 4 because already your inverter it can charge this 2 battery in the same time if you want to charge it only one. Because the tubular, how many amps we charge the tubular in general?
20 to 30 amps.
Yeah, 20 to 30 amps. The maximum is 30 amps. The maximum. The 20 amp we recommend to charge your tubular battery. But you have Ragnar, it have 120 amps to charge your battery. That means you can add 4 series, parallel 4 series, parallel 4 series. In the same time, it will charge three system of the battery in the same time. You understand? This is the advantage when you have a high charging current. Okay. Also, it's important. We all know about the range or the maximum voltage for input for PV. Some engineers they add maybe 6 PV series, then they add 6 PV series and make the 2 series in parallel, right? Then 6 also and in parallel. He keeps the voltage in the same amount. He didn't reach 500, but he reached up to 27 amps or 26 amps. So you have to notice here, your inverter input, how many amps, so you will not damage your inverter. As Engineer Russell said, you have to read the data sheet for any product you will buy it. And you have to read the user manual before you install it. Now, if you bring 6, then or 4, not 6, 4, and put it series, then parallel 3 of them. You didn't reach the maximum power as a wattage, and you didn't reach the maximum voltage, but already you are up of the amps, so you will damage your inverter, sure. Any inverter you will damage it. Okay, only this one we have to notice my inverter how many amps for input, because there is a lot of engineers they didn't care about this one. They care about how many voltage but not how many amps. Okay,
Another question.
no question? Okay, good. Watch.
Feel free to ask question, please. Okay.
You don't have question? Okay.
Question here. So, because of your explanation,
Made mention of connecting in parallel. That connection is not really clear to me. You were saying the port 1 should be connected to the port 2 of the.
No, 2 to 1.
Okay,
But 2 to 1.
2 to 1.
Yeah, 2 to 1. Then you will close the beginning
Okay.
by RG and the ending by RG. From 2 to 1, 2 to 1, 2 to 1.
you mean RG, you mean there's a small double that like
Yeah, small one.
Okay.
That's how you connect.
like something like this.
Yeah, like-
not exactly like this, something like this. So it has the ports that you can, they come with the inverter.
Okay.
Usually come with the inverter. So you see the parallel ports,
Put it here.
you understand it. So you know how you connect it. So if you are paralleling, you put the first one here and the second one at the second port.
At the second port.
You understand? Then
The cable goes from port.
Okay. Not to plus minus.
because we have two parallel ports, one for the ROG, one for the cable. Do you understand now?
But if you have a 3 inverter from 2 to 1, 2 to 1, then you will close the first one and the end one.
All this information is still within the manual.
Yeah.
The exact movement of that wire, you still see it within the manual. So if we're saying from 1 to 2, it seems confusing. Yeah, but don't worry, it's still, you see the diagram.
Yeah, you can see it in the manual.
So that's how we see it. You consult the manual, it will help.
Okay. Question?
Please try to repeat the
3 phase? Okay. The 3 phase, you can do it. Okay. First of all, let's talking about the settings. You will enter the settings from here, from the enter long press. You will have 4 pages. You will enter the first page, 1 press, it's a quick one. Then you will choose 1, 2, 3, 4, 5, 6, 20, like this. 1, it's for type of the battery. You will choose lithium or flooded or AGM. You will choose your battery. Second one for BMS, it's 0 or 1. We have two value for BMS protocol, 0 or 1. If you choose 0, that means it's default BMS. If the inverter it's not communicated or don't know about this BMS protocol, put it easily, put it 0, default BMS. So it will read this lithium battery, but without communication blinking here. If you put it 1, you will see the blinking here, BMS, it's working. Okay? Then you will go to parallel settings, it's number 20, I think, it's number 20. You will choose, you have many choices. It's working as a signal only, this inverter. Second one, parallel signal. Yeah, that means it's parallel but signal single phase. The third option, it's parallel but 3 phase. So you can choose parallel phase 1. Then you will choose the second one, parallel phase 2. It's you can see it here, they write it parallel phase 1, phase 2, phase 3. But when you did your parallel, please, when you did this parallel, you will on the first inverter, did the parallel settings, then off it. You will go the second inverter, did the parallel settings, then off it. The third inverter, do the same, do the parallel setting and off it, then you can on 3 inverter together. Okay, this about function settings. About the cable, you need to repeat the cable also? You need to repeat the communication cable, how you connect it?
You want her to explain the communication cable?
No? Okay. This about settings for parallel. It's clear? You didn't understand my language? Okay, because I'm not native English actually. I speak Arabic, so okay. Yeah. Okay, thank you. Okay, so this about Ragnar. Any question again about Ragnar? Please guys, as I said, when we finish we have a question. We're coming here because we want you to know about our product. We want you to know more about solar parameters in general. If you see now, I'm not talking only about this. I'm talking in general. If you get any inverter, if you do anything, please do this and do that. Because this one, we face it here. And we know how we will avoid it.
Yeah. Made mention about VMS ports. Can you share more light on it? And about the frequency?
Frequency 50 and 60.
50 and 60 on this product.
Yeah, 50 and 60.
I'm not so
This inverter, it's 50 and 60. And the BMS port, this one, it's here. This is a BMS port.
Come and see it.
Yeah, if you want, come and see it. It's writing here BMS. Here, write it BMS. Okay. 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 Also, I will give you one information. It's not about the products. If you want to connect BMS between inverter and battery, and you notice that the inverter, it's not communicated BMS. What you will do? This advice as engineer, not bring the user manual for the battery, bring the user manual for the inverter, any battery and any inverter, and open the bin. There is, I don't know if we can bring it from here. The user manual for. You have the user manual for Ragnar? Okay, there is a board or a page in the user manual. They mention this cable or this board is taking ports. So they write RS4851 number 1 because this RG it's coming 7 pins. I don't know if we have cable. I want to show it to you. For example, this one, this communication cable is coming with the battery, for example, but it's coming here with RG, right? You can see here, it's 7 color cable, right? All of you see this cable, it's 8 cable, I mean. 8 color, right? Okay, you can open the user manual and see this cable RS4851 and R or A, they write it 1 or A, RS485B or 2. And you will see it in your battery, for example, Felicity battery, they take 1 and 2, the bin 1 and 2, okay, for RS4851 and RS4852. They take the bin 1, the bin 2. For our inverter, for example, if you check the user manual, you will see the port inside the inverter, the RS4851, it's number 5. And RS4852, it's number 7. So what you will do to communicate? You will cut the cable and bring that cramping machine and the new RG. You will put the cable from the battery parts on 1 and 2, then you will clamp it. On the inverter part, you will put it 5 and 6 and clamp it. It's easy. Okay? Okay. Okay, that's all about the Ragnar. Any question? So you have to be also looking for the quality products, because when you have installation, you will not have that headache from your customer. And also you have to check the feature in the battery you will take it. For example, you will see this, for example, this 11 kilo. 10 kilo in the market, the same 10 kilo or 11 kilo, or also 15 kilo in the market. If you bring this battery and bring that battery and check it on the same load, you will see the backup time.
She's saying that their battery have grade A cells, so they don't want to bring a recycled cells battery to Nigeria or refurbished cells. You understand? Do you understand what we call refurbished cells? Yes. Like all these electric cars, when 16 cells is inside a battery pack, particular cell is damaged, usually they're supposed to go and recycle it, and what they do is that they pick out the good cells. What some companies do, not them, they pick out the good cells and feed it into a lithium case and replace that particular cell and rebrand it and sell it in the market in a very cheaper price, because there's a price war in the market. But they use a brand new cells. You understand? So because the quality of the cells inside their battery is strong, and the price may not be as exactly as the price of other batteries you see in the market, but they are still price friendly because they are quality conscious. You understand?
Okay. So also the information you have to get it from the data sheet. The weight of the battery, it's very important to check how many kg your battery. If you see the 11 kilo, the same weight of 15 kilos, that something wrong. It's not possible. Okay? And to check how many cycle the battery, how many cycle. Our battery, it's 6,000 cycle. 6,000 cycle in general. The lifespan for this battery, it's how many years? It's up to 12 to 15 years, the lifespan. So how I can guarantee my battery for 5 years if I am not sure my battery lifespan it's up to 10 or 15 years? I can guarantee. Some battery here in the market, if your battery have issue after 1 month, you take your battery to the service center. When your battery enters the service center, the warranty it's broke. No warranty after that. It's not your fault, but they do that. Okay? This is what happened. So you have to be careful about what you will choose, especially for lithium. Also, we have fire protection inside our battery to avoid if there is overcharge or over discharge or overheater in the cells. So I will not have any explosion. You have to be sure. And the iron phosphate in general, it's more compatible with high temperature than lithium ion. So also you have to know what's the difference between lithium ion, normal one, and iron phosphate battery. 6,000 cycle and the DOD. What's the meaning of DOD?
Depth of drilling. Depth of drilling.
Discharge. Deep of discharge. Yes. Yeah. Okay. That means the 6,000 cycle. When you mention your cycles and your battery, you have to relate this cycle to the DOD. So 6,000 cycle at DOD 95. That means when your battery reach to 100%, then 5%, this one cycle. 100 to 5, 100 to 5, one cycle. But if the DOD in your battery, it's 20%. That means from 100 to 20, it's one cycle. You understand what's the difference when you mention 6,000 and the DOD it's 90 or 95? Where is the difference in the value or in the quality? So you have to check the each cell voltage. If it's 3.2, that means it's iron phosphate cell. Lithium ion, it's coming actually 3.6 or 3.7. And how many cell you have? How many cell? It's 16 cell. 16 cell times the 3.2 volt. 16 cells times 3.2 volt. 51.2, right? 51.2 times 5 times it's 300 amps. How much? 15,360. But if they reduce one cell, only one cell, not 16, 15, the voltage, it will be how much?
volt.
48 volt times 300, 14,400. So it's not reached to 15 kilowatt at all. In general, if your battery 15 kilo, you can't use the 15 kilo, right? Because the DOD and the discharge current. So if your battery, in the fact, it's not 15. So that means maybe you will not reach to 12. Okay? Okay. This about lithium battery. The charging current, you have to read it here. And also the parallel. The parallel in the lithium battery up to 16 pieces. Okay? 16 battery in parallel. 16, 1-6. Also here, please engineer Iyad. Okay. When you connect your battery without BMS, if you connect your battery without BMS, you have to notice this value. Maximum charging voltage and the floating voltage. It's 57.6. That means in most inverter, the floating voltage, it's coming 56 volt, right? If you connect your battery, your lithium battery, to this inverter without adjust this one, that means you didn't reach to fully charge at all. You didn't reach it. Your battery, it's not fully charged. So you have to adjust this value if you didn't connect the BMS. Okay? Okay. Battery here, we have four terminal and we have a breaker. This one, the advantage of this one, if you have parallel more than 2 or 3 batteries, so you will not use bus bar box, you can use it from here. Okay? We have 4 terminal, we can use it for parallel because this battery is taking parallel up to 16. Okay? We have a breaker here for on and off, but the most important is this one. This is small switch on and off, and this DIB switch. This dry contact also. You can connect it also to generator or what else you need to on and off. This RS 4851 can. RS232, 4852, 4853. How we parallel battery to battery? Focus on this one. From RS4851, always in the master battery, I will consider this one is the master battery. From 1 to the BMS inside the inverter, always. From the master to the inverter RS4851. Then from master inverter to slave inverter, I will go from RS4853 to RS4852. Then RS4853 4853 to RS4852. Like this. The parallel is very easy. Then the DIB switch, in the master battery, I have to put it 1000. Slave battery 0100. Third battery 0010. Like this. This DIB switch is very important. The inverter, it will not detect the battery if you didn't do this DIB. It's very important to do it. Okay? Okay. This battery 5 years warranty. This light
5 years, yes.
5 years, yes. This light, it's coming up when it's charging, so you can see it. Yeah. This is all about the lithium battery, low voltage. When you want to connect any inverter with any lithium battery, you have to check this box. Check this one here. This is the BMS port. It's 1, 2, 3, 4, 5, 6, 7, 8. It's 7 ports. Check in your inverter and your battery this is scheduled. So we will see RS485A and RS485B. It's number 7 and 8. And you will check in your battery. It's which number. Then you will cut the cable and put it in the RG, how it's here, and clamp it again. So in this way you can have a communication between battery and inverter, any inverter and any battery. Okay, let's go to high voltage battery. What we have, high voltage battery. This battery rack, each rack it's 50 kilo, 50. This battery is 10 battery racket inside. Each battery it's 5 kilo, 5 times 10, 50. Each battery voltage it's 51.2. In high voltage battery, we connect this battery in series or in parallel inside the cabinet. Yeah, this battery between 1 to 2, like this. 1, 2, 3, 4. We connected series or parallel? Guys, I have one question. Inside cabinet, this cabinet, I have 10 battery. This battery, it's connected in series or in parallel? In series, okay. So the voltage for this battery, how much? I said each battery, it's 5 kilo, 51.2 volt. 512 volts. That means we are in a high voltage battery. 512 volts. Each cabinet is 512 volts. This battery have Wi-Fi. Also, you can monitor your battery on your application on the app. And this battery, it has fans on up, 4 fans for cooling, and wheel, so it's easy to move it. What else? Okay, and this battery, how many cabinet I can connect in parallel now? How many cabinet? 4. I can connect in parallel 4 battery. That means I can reach to 200 kilowatt hour. This project, for example, the total battery backup is 600 kilo. Each 200 connect to inverter. 200 to inverter, 200 to inverter. The inverter is 50 kilo high voltage source. The total load is 150 kilowatt hour. Also, the warranty on high voltage battery is 5 years. Solis 50 kilo inverter, it's available in Nigeria. This battery also available in Nigeria. If you have any projects, you need our support to design. As Engineer Russell, he said, we are ready. And if you have any issue, also we are ready to solve it. Okay? Any question? No question? I will ask. If you didn't ask me, I will ask you.
Made mention of the DOD of 6,000 cycle, which is 95%.
25?
95%. The DOD.
DOD, it's
Yeah.
95.
95.
Yeah.
What is the level of the discharge that will be?
5%, the level of discharge.
Okay.
Yeah, it's 5%.
Okay.
You can reach to 5%.
Okay.
But for me as engineer, I don't prefer to reach to 15%. Even if in this high voltage battery, the R&D, they told me you can reach to 10%, and don't worry, the battery, it will wake up again. But when I do this project, I put it 15 because I will be satisfied and I will be relaxed. So you can read what there is in the data sheet, but do the standard engineering. Okay? So you can reach to 5% and you don't have that issue. But use the BMS communication. Okay? So if you reach to 5% and you didn't connect the BMS, the battery, it will drain and it will block until we do refresh again for the battery to wake it up. So you have to use Ragnar or Amoma with wake up function, or you have to use Ragnar with BMS. I mean Amoma or Rico with wake up function, or Amoma with BMS communication. You don't have another choice. If you choose another inverter without wake up function and without BMS communication, you have to adjust the voltage, this cut-off voltage 48 at least 48. Okay, that clear? What's the difference? Because if you connect the BMS, if you connect the BMS, you don't need to do anything. Okay, you have question? You have question? Okay.
Yeah, I'm sorry. I want to ask based on the DPI switch.
Okay.
So like if we have the way you explain, like if we have them in parallel, how we can configure the DPI switch for lithium batteries?
How we can adjust it?
Yes.
Okay. Yes. For the master battery, you have to put it 1000. Slave battery, the second one, 0100. Third battery, 0010. Like this. And the remaining you can see it in the, if you have up to 16, you can see how you can do it by the user manual. But it's very important to do this one, this part. Okay? Okay, you don't have any question? Okay, thank you very much. Thank you.
Thank you. Congrats. Thank you, sir. Next on the list, Mr. Tohid Olalekan. Oh. A round of applause for him has come. Congratulations. The next on the list,
I want more than this.